Number 76 says, evaluate the following definite interval, the interval from 1 to 4 of 1 over the square root of 6t plus 3 dt. So this is definitely use substitution, and it's not a natural log situation because even though it's just an expression in the denominator, it's not raised to the power of 1, it's raised to the power of 1/2 in the denominator. So we're going to use u equals 6t plus 3, du equals 6 dt. We don't have a 6 hanging out, so it's got 1/6, the integral of u to the negative 1/2 du. And we cannot put the 1 and the 4 back, okay? Because this is a different variable, and so 1 and 4 are the limits of integration for t, not u. Now, you could go back to those if you go back to t at the end, but I like to go ahead and plug them in just to get that done early. So u of 4 is 24 plus 3, that's 27. And u of 1 is 9. So it's from 9 to 27 in terms of u. So the antiderivative is add 1 to the power, divide by the new power, dividing by 1/2, so it's multiplying by 2, so that's 2 times 1/6, that's 1/3, evaluated from 9 to 27. So that'll be 1/3, the square root of 27 minus the square root of 9, that is 3 root 3 minus 3 times 1/3, so that is the square root of 3 minus 1. That would be my final answer on that. Yeah. Just making sure I didn't mess it up, because of course they have something different, but I don't think I did. I don't power to the new power to 2, so 1/3. Okay. Yep. I feel good about it. Okay. So 77. 77 says evaluate the definite integral, the integral from 1 to 7 of e to the 2 square roots of x over the square root of x dx. So this has a couple contenders for, well, potentially, you might think, oh, the denominator will make that u, but here's the thing. This is a function within another function. I know the antiderivative of e to the x is e to the x. I know the antiderivative of e to the u is e to the u. But the antiderivative of e to the 2 square roots of x, I need to rewrite, because I have to have it as e to the x, or e to the variable. U equals 2 square roots of x, which is 2x to the 1/2. Du, so power down to the front, so that's just 1, x to the negative 1/2 dx. Well, this right here is 1 over the square root of x dx. We have that. We have 1 over the square root of x dx. So all of this is replaced with du, and then this is replaced with u. So we really got the integral of e to the u du. I'm going to go ahead and evaluate at my endpoints. So I'm going to plug in 1, 2 times the square root of 1 is just 2, and then 2 root 7. So the antiderivative of e to the u is e to the u. Evaluated from 2 to 2 root 7. Final answer is going to be e to the 2 root 7 minus e squared. Again, yeah, something completely different, but I don't see what the issue is. U is 2 square roots of x, 1/2, u 1/2. Okay, 78. So 78 says, find the indefinite integral, the integral of x over negative 4x squared plus 9 dx. Alright, we are going to let u be the denominator because its derivative is a linear term, or a linear function anyway, and we've got a linear x in the numerator. So u equals negative 4x squared plus 9. Du equals negative 8x dx. We have an x dx, we don't have a negative 8, so negative 1/8, the integral of 1 over u du, which is negative 1/8 natural log of the absolute value of u plus c, and u is, I'm going to say 9 minus 4x squared plus c. And there we go. 79. So 79 says find the integral of 1 over x natural log of x to the 12 dx. Alrighty then. I'm going to let u be x to the 12th. Am I? No, I'm not. No, nope. I'm going to use log properties. I'm going to move that 12 to the front because otherwise I don't have a 12x to the 11th anywhere. So I'm going to say 1 over 12x to the natural log, or 12x times the natural log of x dx. And then I'm going to let u be all of this, ln of x. And du is 1 over x dx. 1 over x dx. So I've really just got the integral of 1 over 12u du. Or 1/12 the integral of 1 over u, which is 1/12 natural log of the absolute value of u. And u is natural log of x. Well, there you go. Interesting. Number 80 is, oh, we skipped 80. '81. Find the indefinite integral, the integral of 1 over the square root of 9 minus 16x squared dx. So this one right here, if you try to let u be the interior of the denominator, the derivative is negative 32x. I can deal with not having a negative 32, but I can't deal with not having an x, so I've got to think something else. And if you think 1 over the square root, if you can make this 1 and this a function squared, then you could think of having your sine inverse, putting it in that form. So what we're going to do is we're going to think of it like, what do I need to multiply the top and the bottom by? So I need this to be a 1, which means I need to divide inside the square root by 9, which means outside I'm going to multiply by 1/3. And I'll explain why. So 1/3 the integral, this is this 1/3. 1 over the square root of 9 minus 16x squared divided by 3 dx. Well, here's the thing. If I want to bring 3 inside, then I have to square it and square root it. So now I've got 1/3 the integral of 1 over the square root of 9 over 9 minus 16x squared over 9, because the square root of this divided by the square root of that might as well just be the square root of this divided by that. You can bring them inside. Dx. So this is 1, and this is 4x over 3 quantity squared. There's my u. So u is going to be 4/3 x. Du is going to be 4/3 dx. I don't have a 4/3. I mean, technically I have a 1/3, so I would just need to get, but whatever. Multiply by 3/4, and you get 1/4 the integral of 1 over the square root of 1 minus u squared du, which is sine inverse of u, so 1/4 sine inverse of 4x over 3 plus c. And there's the answer to that. 82. 82 says find the integral of x minus 15 over x squared plus 1 dx. This I am I'm gonna split that up. You could do it a couple different ways. You could do u equals this and du equals, but I think it's just easier to go ahead and x over x squared plus 1 minus 15 the integral of 1 over x squared plus 1. So here's where my mind went. The derivative of x squared is 2x, so I've got an x. Cool, I can do u substitution. I thought, well, if I bring the 15 out, this is just 1 over x squared plus 1, and I recognize that that is tan inverse. So over here, u equals x squared plus 1, du equals 2x dx. I don't have a 2, so 1/2 the integral of 1 over u du. That is 1/2 natural log of the absolute value of u, x squared plus 1. Now, technically, x squared plus 1 is always positive, so you could get away with dropping those absolute variables. And then this one right here is minus 15 tan inverse of x. And that's all you gotta do. I wonder what happened. Like, so if I just left it. X minus 15 over x squared plus 1 dx. Yeah, if you let u be x squared plus 1 and du be 2x dx, like this is not x times dx, this is x minus 15 times dx, so it needs to be split up. Alright, 83. Evaluate the integral. Do I have space? Kind of, if I do it small. Let's see. 83. The integral from the square root of 3 to 30 of 12 over 9 plus x squared. So this is looking like a tan inverse if I can make that 1 and I can make that something squared. So I'm going to multiply by 1/9. So that is going to be 4/3 outside. The integral, still from square root of 3 to 3, I haven't done any substitution yet, of 1 over, I always bring that out to the front, 1 plus, and we're going to go ahead and say x over 3 quantity squared. So you can rewrite x squared over 9 as x over 3 quantity squared. So, alright. So I'm going to now do u substitution with u being x over 3 and then du being 1/3 dx. I kind of do have a 1/3, but if you just think multiply by 3, it just goes away. So I've got 4 times the integral of 1 over 1 plus u squared du. I'm going to go ahead and plug them into u. So square root of 3 over 3. And which is just really 1 over the square root of 3. Bah, whatever. And then plug in 3, and I get 1. So I've got 4 times tan inverse of u evaluated from the square root of 3 over 3 to 1, which is 4 tan inverse of 1 minus tan inverse of the square root of 3 over 3. So here's the thing. You got to know your unit circle, which you all do, which is so wonderful. Tan inverse only exists from 0 to, or from negative pi over 2 to pi over 2, and tangent is only positive up here in the first quadrant. So I know that this coordinate point is 1, 0, which makes this 1/2 and this square root of 3 over 2. Tangent right here is sine over cosine, 1 over the square root of 3, which is square root of 3 over 3. So tan inverse of square root of 3 over 3 is tangent of what angle equals square root of 3 over 3? So that right there is pi over 6. And then tangent is 1 when you've got the same thing. So this is square root of 2 over 2 and this is square root of 2 over 2. Something divided by itself is 1, and that happens at pi over 4. So we've really got pi minus 2/3 pi. This is, oh, sorry. So pi minus 4/6, so 2/3 pi. Pi minus 2/3 pi. Pi is 3/3, so 3/3 minus 2/3 is 1/3 pi. So pi divided by 3 is my answer. 84. So 84 says find the integral of x squared minus 14x plus 10 over x plus 12 dx. I think we're going to need to do long division here, or synthetic division, but whatever. So x plus 2 goes into x squared minus 14x plus 10. X, so that's x squared plus 2x, subtract, and we're left with negative 16x plus 10, so minus 16, negative 16x minus 32, subtract, and I'm left with 10 plus 32, so 42. So this is equivalent to me asking you to find the integral of x minus 16 plus 42 divided by x plus 12. Which means that this can be done by splitting it up. Yeah, sorry, I was just checking something. I don't know where they get the numbers from, but whatever. Okay, the antiderivative of x is x squared over 2. The antiderivative of 16 is 16x. And the antiderivative of 42 over x plus 12, technically that's u substitution with u equaling x plus 12, du equaling dx. And then you got a 42 up top, so 42 times the integral of 1 over u. But it's just 42 natural log of the absolute value of x plus 12 plus e. And there's your answer. 85. Use Euler's method to make a table of values for approximate solution for the line integral. 5 steps of 0.15. Dang. Okay. Okay, we've got an initial value of y of 0 equals 2. I'm supposed to use 5 steps at 0.15 each, with y prime equaling 4x minus 2 plus 2y plus 2y. Okay, so x, y, starting at 0, 2, going up 0.5, so 0.15, 0.3, 0.45, so that's 1, 2, 3, 4, so 0.60, and then 0.75. So we're supposed to evaluate y at 0.75, or get an approximation for it. I don't know about this. Huh. Maybe stuff's a lot smaller. Or a lot larger, I mean. Nah, whatever. That's what's written down, so that's what I'm going to do. Okay. dy dx, the value of the derivative, and dy, how much we're going to add, and every time we multiply by dx, and that changes 0.15. So just a reminder, dx is 0.15. Or 15/100ths. But I think this is going to have to be a calculator question because they're going to get kind of hairy. So when I plug in the 0.02 into the derivative, I get 0, I get 4. I multiply 4 times 0.15, 4 times 0.15, and I get 0.6. Add that, and I get 2.6. So when I plug in 0.15 and 2.6, so 4 times 0.15 plus 2 times 2.6, you get 5.8. 5.8 times 0.15 is 0.87, and so we add 0.87 plus 2.6, and that's 3.47. So I'm going to plug 0.3 in for x and 3.47 into y, so 4 times 0.3 plus 2 times 3.47. Oh, what did you not like? 0.3, and we get 8.14. 8.14 times 0.15, that gives me 1.221. Add that to 3.47, and you get 4.691. Plug that in, so 4 times 0.45 plus 2 times 4.691. That gives me 11.182. Multiply that times the change in x, so times 0.15. 1.6773. Add that to 4.691. 6.3683. Plug that in, so 0.6 times 4 plus 2 times 6.3683, and we get 15.1366 times 0.15, 2.27049. Add that to 6.3683, and the approximation is 8.63879. Well, that was fun. So if I ask you to do it by hand, obviously the decimals won't be that crazy. If there are decimals, it'd be something you could simply put into fraction form. But cool. Process is the most important thing. 86. Solve the differential equation. dy dx equals negative y minus 8. So just remember, the first step in a differential equation is separate the variables. You cannot add and you cannot subtract y over. You have to multiply or divide. In this case, I'm going to have to take it all in. So 1 over, I'm going to leave the negative. Now, I don't know if a lot of you would think to do this, but the reason why is because then I don't have to worry about an extra thing with natural log, because if I do it as 1 over negative y minus 8 dy, then when I do a u substitution, I've got this negative dy that most people are going to forget. Negative natural log of the absolute value of negative y minus 8. And that's just a whole bunch of headache. So if I can factor out the negative and leave it on this side, then it's a lot easier on myself. So in this case, u is y plus 8, du is dy. So it's really just the integer of 1 over u, which is natural log of the absolute value of u, which is y plus 8. Natural log of the absolute value of y plus 8. Negative x plus c. I'm supposed to solve, so I'm going to raise both sides to the power of e. Absolute value of y plus 8 equals e to the negative x plus c. That's e to the negative x times e to the c, which is just another c. Maybe you could put like a c1, so it's a different c, but whatever. So the absolute value of y plus 8 equals c e to the negative x. We're gonna, in order to get rid of an absolute value, you put plus or minus, but the c can absorb that, and we subtract the 8. So it's negative 8 plus or minus whatever c e to the negative x. All right, number 87. So 87 says solve the differential equation y prime equals the square root of x over 2y. This is dy dx, same thing. And normally I would say just take as little as possible, but in this case the 2 would be useful to bring over because the antiderivative of y is going to be y squared over 2. But if I have that 2, then I don't have to worry about it. So I'm going to bring the 2 up with it. 2y dy equals the square root of x dx. Integrate. Y squared equals, add 1 to the power, divide by the new power, plus c. Take the square root, so y equals plus or minus, because we don't know, 2/3 x to the 3/2 plus c. And that would be my final answer. 88. Find the function y equals f of t passing through the point 0, 12 with the first derivative given by dy dt equals 6/7 y. So this is a particular differential equation as opposed to a family. So we're going to separate the variables, divide by y. So 1 over y dy equals 6/7 dt. The antiderivative of that is natural log of the absolute value of y equals 6/7 t plus c. We're going to plug in 0 and 12. So natural log of 12 equals c, which means natural log of the absolute value of y equals 6/7 t plus the natural log of 12. Now, from here I'm trying to solve for y. So what we're going to do is we're going to raise both sides to the power of e. But then I remember that the absolute value bars are still there. And this right here can be split up as e to the 6/7 t times e to the natural log of 12, which simplifies down to just 12. So this is the absolute value of y equals 12 e to the 6/7 t. Y can be either the positive or the negative, so when you get rid of the absolute value, you put plus or minus, and then you'd have to decide, and the way you decide that is by going back to the original coordinate point. At 0, it's supposed to be 12. So when I plug in 0, 6/7 of 0 is 0, e to the 0 is 1. It's got to be positive 12, so final answer, y equals 12 e to the 6/7 t. Okay. 89. 89 says, write and solve a differential equation that models the following verbal statement. Evaluate the solution at specified values of the independent variable. Writing your answer. Let's fold that up. All right, so we've got the rate of change of p is proportional to p. The rate of change of p is proportional, some constant of variation, to p. All right, when time equals 0, population equals 60. When time equals 5, population equals 84. P equals what when t equals 11? So, okay, let's answer derive first. So we're going to separate the variables. 1 over p dp equals k dt. So this is natural log of the absolute value of p equals kt plus c. Raise both sides to the power of e. Absolute value of p equals, well, I'm going to kind of play around with it. I'm going to do this right here. First, I'm going to solve for k and for c. First, if I plug in time equals 0, so the coordinate point 0, 60. Then I've got natural log of 60 equals 0 plus c, so c equals natural log of 60. So kt plus the natural log of 60. And then if I plug in the coordinate point 584, then I've got natural log of 84 equals 5k, because t is what I'm plugging in for, plus natural log of 60. So divide by, or subtract natural log of 60. So natural log of 84 minus natural log of 60, all divided by 5 equals k, which same thing as natural log of 84 divided by 60. Divided by 5, or 1/5 that. 84 divided by 60 is 42 30ths, so 21 15ths. So 7/5. 7/5? Yeah, times 12. Yeah, that makes sense. So natural log, so 1/5 natural log of 7/5. Dang, how am I going to make it to where I can't fit it? I have to go up here. Okay. Equals k. So I'm going to go back to here. Natural log of the absolute value of p equals 1/5 and, well, yeah, 1/5 the natural log of 7/5 t plus the natural log of 60. And then I want to solve for p. So we would raise both sides to the power of e. Absolute value of p equals 30 this 1/5, if I bring it back as a power, then I can simplify that out. So that's natural log of 7/5 to the 1/5 power, if you will, times t. So e and natural log cancel each other out, and then so it's times this, e to this times e to that. So I've got 7. That's not times t though. I'm just gonna delete that there. Just kidding. The t is problematic. Just gonna leave it. Although I am going to split it up. E to this times e to that, and e to the natural log of 60 is 60. So 60e to the 1/5 natural log of 7/5 t. And then in order to get rid of the absolute value, you do plus and minus. But the initial condition was 0, 60, positive 60. So I'm just going to go ahead and say the positive 60e to the 1/5 natural log of 7/5 t. They want to know what it is when t equals 11. So 60e to the 1/5 times the natural log of 7/5 times 11. Then we get 125.7862, which is what they got. So when t equals 11, population is around, or whatever it is, 125.786. I want to play with it though for a second. What if so we said natural log of the absolute value p equals kt plus c. What if we gone ahead and solved for p? Then we would have had absolute value of p equals e to the kt times e to the c, which is just another c. So absolute value of p equals c e to the kt. The absolute value bars can be absorbed into c, so c e to the kt. That might have been easier. So then when time equals 0 and population equals 60, 60 equals c e to the 0, that's just 1, so c equals 60. So population equals 60 e to the kt. And then 5 and 84, so 84 equals 60 e to the 5k. So just plugged in for time. Divide by 60, 84. And then 5k. I take the natural log, divide by 5, so same thing. Okay, kind of up to you. So you can either solve for the population and use this form to solve for c and for k, and then plug in time equals 11, or you can work it out. I kind of almost prefer this method for that one. But I don't want to take up too much more room. I might do it out over here if I have enough space. Yeah, I'll just do it. Whatever. So, 4. Natural log of the absolute value of p equals kt plus c e e. Absolute value of p equals c e to the kt. P equals c e to the kt. Using 0, 60. 60 equals c. P equals 60 e to the kt. Using 584. 84 equals 60 e to the k times 5. K will equal that. So then you end up with p equals 60 e to the 1/5 natural log of 84 60th t. Plug in t equals 11, and there you go. That's whatever you see. Okay. Last one, 90. Where's the question? Where are the questions? Oh, it's right there. So 90 says find the particular solution to the differential equation dRds equals e to the r minus 7s that satisfies the initial condition r of 0 equals 0. Blah. S's. Okay. In fact, I'm going to make an X. All right, I need to split this up because I've got r and x both in the variable or the power of e, so I've got dr dx equals e to the r times e to the negative 7x, which also means dividing by e to the 7x, but we'll just do that in a second. So I'm going to divide by e to the r dr, and then I'm going to put 1 over e to the 7x dx. So I divided by e to the r, multiplied by dx, e to the negative 7x. Well, shoot. I want to come up, bring that back. Okay, so this is the integral of e to the negative r dr equals e to the negative 7x dx, the integral. Each of these requires u substitution. U equals negative r, du equals negative 1 dr. I don't have a negative 1, so negative the integral of e to the u is just negative e to the u, which is e to the negative e to the negative r. So negative e to the negative r equals, this one requires u substitution as well, u equals negative 7x, du equals negative 7 dx. I don't have a negative 7, so negative 1/7, the integral of e to the u. I guess I should say v maybe. Okay. So the antiderivative of e to the v is e to the v, so negative 1/7 e to the v, which is negative 1/7 e to the negative 7x, plus c. We're going to use the initial condition 0, 0. So when I plug in 0, I get e to the 0, that's negative 1. E to the 0 is 1, so that's negative 1/7 plus c. Add 1/7, negative 1 plus 1/7 is negative 6/7. So c equals negative 6/7. Negative e to the negative r equals negative 1/7 e to the negative 7x minus 6/7. Divide by the negative, plus, plus, plus. Take the natural log. Negative r equals natural log of the absolute value. I don't know why I did that. 1/7 e to the negative 7x plus 6/7, and then make it negative. 1/7 e to the negative 7x plus 6/7, and there's my answer. Okay, and there's your review.